Hi everybody, it's me. I'm trying to mess around so that you can actually see me, and hopefully we'll be able to have some fun and do more math even though I'm stuck in my house. This is my house. And I am not with you. Remember, as I'm making these videos, it is really hard for me to know if I'm giving you what you need. I don't know if I'm doing enough examples. I don't know if the examples that I am doing are good enough for you because you're not in front of me, so I don't know if you're getting what you need. It's really important that if you're not getting what you need, that you tell me, either through comments on the videos or emails or comments in Google Classroom. However it is that you need to get a hold of me, let me know if there's more that I can be doing. All right, so hopefully I'll be able to. Are we ready for some inverse functions? So inverse functions are the second part of section 10.1. So far we've looked at composite functions, and then we looked at one-to-one functions. Now, inverse functions are pretty nice because they are actually something that they undo each other. The idea is that if you have inverse functions, that one of them will undo the other. And we'll look more in a few minutes as to what that really means. We looked at one-to-one functions because a function has an inverse only if it's one-to-one. If I have a one-to-one function, then I can find the inverse, and my inverse is also a function. If I have a function that is not one-to-one, then it doesn't have an inverse that is also a function. And we want things to be functions so that we can use our function notation and that we can really use them. So that's why we've looked at those one-to-one functions. Let's look at the idea of what happens with an inverse and what it actually is. So let's start off by looking at a function itself, like this one right here, 0, 1, 1, 2, 2, 4, and then 3, 6. And remember that when we looked at this before, all that this function does is it takes a 0 and it maps it to a 1. It takes a 1, maps it to a 2. It takes a 2 and maps it to a 4. Then it takes a 3 and then maps it to a 6, right? That's all that that function does. So if I want to look at the inverse is going to work backwards. The inverse, it undoes what was done. So instead of going from 0 to 1, it's like it's at 1, but now it's going to 0. It's like it's at a 2 now, and it takes that 2 and it turns it into a 1. So it's undoing whatever was originally done to my function. So f inverse, and the notation that we use is this little -1 here. So f to the -1 inverse, f inverse of x, is going to be this. I've got 1, 0, 2, 1, 4, 2, and 6, 3. Okay, so for this is what this function looks like as its inverse. If we want to look and see what the relationship is here, I had 0, 1, now I have 1, 0. I had 1, 2, this one took 2 and put it back at 1. Right, this one took 2 and put it at 4, this one takes 4, puts it back at 2. It does the backwards. So if you're given points, then we just switch our x and y to find your inverse function. So why don't we go ahead and look at this on a graph. I've got a nice little graph drawn up here if I can find it. And we're going to go ahead, I'm going to use a different color so you can easily see what happens and where my inverse shows up. I'm going to use, let's go with red because that'll show up really well. Okay. So if I have the point -4, 4, in order to get my inverse, I'm going to have to switch those two. So instead of being -4, 4, it's going to be 4, right? So I'm going to go over a positive 4 and then down 1, 2, 3, 4. So this point right here comes way over to here because I've switched my 2 points, my x and my y. This one right here is 0, 3. Well, it's going to become 3, 0. This point right here is 3, 2. Well, now it's going to become 2, 3. And then this point right here is 4, negative 1. Well, now it's going to become negative 1 and then up 4. So I'm going to take my ruler and I'm going to connect these so we can visualize them a little bit better. Dunk. Bonk. And then bonk. Now, if you notice, some of you might not have noticed, but if I have this line y equals x, do you notice that this is a reflection across it? It's been reflected across there. If you think back to your reflections in Math 1. Anytime that we're looking at an inverse, if we want to find it from a graph, we could look at just the reflection across there. A lot of times it's easier for us to do it algebraically though. So if we're given points or a graph, we should be able to find what that inverse function looks like. So let's go ahead now, see what happens if we're given actual equations and how we could do this, because there's more to it than just, plugging in points and switching them around. Remember the idea of an inverse, so two functions are inverses. Oops, you can't see what I'm writing. Darn it. There we go. If f of g of x is equal to x, and g of f of x is also equal to x. So what that means is that if I have a function f and I plug g of x into it, it should cancel out anything that f did. And likewise, I'll make sure that looks like a real O there. If I have g and I plug f of x into it, it should cancel out whatever g did. So I'm going to look at two examples. I'm going to look at f of x is going to be x plus 4. And then I'm going to look at g of x being x minus 4. And take a moment and look at those two functions. If I look at it and I think to myself, what's happening in this one? Well, I'm taking x and I'm adding 4 to it. Then what's happening in this one? Well, in this one, it's subtracting 4. So these are inverses because they undo each other. Now, these are really obvious examples. There's some later on that are not very obvious. So what I'm going to do is I'm going to see if this holds true. For these two functions, I'm going to check to see what's f of g of x, and then I'm going to see what's g of f of x, and then go from there. Remember, initially we can rewrite these. It's just those composite functions that we looked at in previous videos. So I'm going to take f of x, and I'm going to plug g of x into it, x minus 4 plus 4. What happens when I drop my parentheses? I've got an x minus 4 plus 4. I just have a plain old x left. For this one, remember, it's just like I've got g of f of x. So that means that I'm going to take my function g, which is an x minus 4, and instead of my x, right, I'm going to plug in what I've got for f of x. And so in this case, I've got x plus 4 minus 4. That gives me a plain old x. Yes, they are inverses of each other. So if I need to check to see if they're inverses, this is what I'm going to be checking. Now, in order to find an inverse, these are a little bit trickier. In order to find an inverse, we want to think back to what we did with points. Remember that if we were given points, we just switched x and y. Right? We switched x and y, and we were able to easily find our inverse function. Hold on a second. The mouse pad's in the way. Okay. Well, we're going to do something very similar, even though we don't have the same situation. I'm going to look at this f of x. is equal to x plus 4. Again, just give us a nice simple example. We know what the inverse should look like, so we'll be able to see if the method that we're going to use works. There's another way that I could write f of x. I'm going to write it as y equals x plus 4. All right, so I switched f of x into a y. Okay, and now I'm going to switch where my x and y are. So instead of y equals x plus 4, I'm going to have x equals y plus 4. Just like when I was doing it with points, I just switched my x and y. Here, I'm just doing it with an actual equation. And now we're going to solve it for y again. So in this case, I'm going to subtract 4 from both sides. So x minus 4 is equal to y. And now I can replace y with f inverse of x. So I've got that f inverse of x is equal to x minus 4. And if we remember from up above, I'm going to scoot this up real quick. I had x plus 4 and x minus 4. Those were inverses of each other. Looking here, I was able to start off, I replaced my f of x with a y. That way it was easier to algebraically solve for. I switched them around, and then I got y all by itself, and I was able to have my inverse. Let's look at another example with something that's a little bit more complicated. Let's look at f of x is equal to a 2x minus 7. Okay. So remember, the first thing I'm going to do is replace that with a y. And then next, I'm going to switch my x and y. So instead of y equals 2x minus 7, I'm going to have that x is equal to 2y minus 7. Now I need to solve for y. So I'm going to add 7 to both sides. X plus 7 equals 2y. Divide both sides by 2. So x plus 7 all over 2 is equal to y. And then remember, this becomes my f inverse of x. So if I've got my f inverse of x is equal to an x plus 7 divided by 2. And if we think about this, the first thing that happens here is it's multiplied by 2 and then subtract 7. So here they add 7 and then divide the whole thing by 2. So it really does undo what was done. Okay, so that's it for 10-1 and your inverses. Hopefully that's enough for you. Remember, like I said, give me feedback. Let me know. I want to give you everything that you need, but if I don't get feedback, then I don't know if you're getting enough. So have a great day, and I'll see you in a little bit for section 10-2. We get to learn about exponentials. Yay!